Fill in our formulas over here. What is the area formula for a triangle? Base times height divided by 2. I'm going to put 1/2 base times height, but you can write it either way. Base times height divided by 2 or 1. Oops, I just did what I'm not going to let you do. When you write these formulas, you need to start with area equals 1/2 base times height. And you may think, what in the world? Why is the big deal? Here's the big deal. They're not going to ask you to just find the area in this chapter. None of this is going to be simple, here's the base, here's the height, find the area. It is going to be, here's the area, here's the base, now find the height. Things like that, where they're going to make you work backwards. If you just write down 1/2 base times height, you have nowhere to put the area. So I'm going to be super picky that you start with A equals, or in perimeter formula that you start with P equals. So if you didn't do that, go back and add that to your formula sheet. All right, what's the area formula for a square? Okay, I heard two different answers there. Be careful. Length times width is true, but that's not the formula really for a square. What's the formula for a square? Okay, it should be side squared. You could say length squared or width squared, but that's not what books are going to put. They're going to put side squared. In a square, the length is the same as the width. So you shouldn't use two different letters. You should have one letter, and it's that letter times itself. What's the area formula for a rectangle? Length times width is correct, but this book is not going to put length times width. They're going to put base times height. I will not count it wrong if you put length times width, but I am going to be consistent so that if you're looking in your book and you're practicing the formulas, that we're putting what the book has, okay? But if you put length times width, I will still give you credit for that. All right, circle, what's the area formula? Pi r squared. Make sure you don't confuse that with the perimeter formula for a circle. So let's go ahead and come over here and write that down. We don't call it the perimeter for a circle, though. What do we call it? Circumference. So I'm going to put C equals, and what's the formula for a circle? 2 pi r. They both have a pi, they both have an r, they both have a 2. It's where do you put the 2? And the way I remember it is, when I'm finding area, what will my units always be? Squared. So the formula that has the square is the formula that has the units squared. So pi r squared, units squared. 2 pi r because circumference is not units squared. Okay, what's the perimeter formula for a square? 4s. Okay, so P equals, make sure you put P equals. Rectangle, what would the formula be? 2b plus 2h. And again, if you put 2l plus 2w, I wouldn't count that wrong, but the book's going to call it base and height. Questions on those? Okay, so right there, that is 7 formulas that are going to be on your formula test that you should have already memorized from chapter 1. The next 4 are going to be the new ones for today. So does anybody know what the formula is for the area of a parallelogram? It is just base times height. Area equals, don't forget your A equals, base times height. The difference for the parallelogram is that in a rectangle, your base and height are 2 of your sides. In a parallelogram, it's not going to be that your height is not going to be one of your sides. Okay? But we'll talk about that in a minute. Trapezoid, does anybody know that formula? Area of a trapezoid. Are you sure? I think you guys might have seen the formula before. No, it doesn't have a 1/3. It does have a fraction in it, but it's not 1/3. There are ways that you could divide it into other shapes, but that's not going to be what we do now. Now we're going to actually learn a formula for the entire trapezoid. Okay, it's all right. We'll come back to it. Rhombus, does anybody know what it is? Okay, how about kite? Okay, so these are new for today, and that's okay. I didn't expect that you would know them all, but I thought you might. When you see them, if you've seen them before, then that'll be good. I will warn you, the rhombus is actually going to have 2 formulas, and we'll talk about that in a minute. Okay, so we're going to jump right in. This notes in the textbook, they're going to try to go through and help you see why these formulas are what they are. For time purposes, I'm not going to spend a lot of time on that. I'm going to show you, here's what the formula should be, here's how they got it, and then you're going to just use the formula. Hardest part today is going to be, do you know the formula? Can you work with algebra? Because today they're going to take everything we do and throw a bunch of algebra in it. And it's going to be problems where you have to distribute and multiply, and so really difficult problems. Yesenia, you with me? Okay, you stand up if you fall asleep. If I have a picture like this to start with, though, that's terrible. Pretend that that looks better. What does that kind of look like? Ice cream cone. They're not always going to be shapes that are just perfect. So what would I do to this shape? Oh, I'm sorry. That would be helpful. Lastly, we kind of need our notes. Thank you, Christian. Being bold there. Everybody else is going to sit there and stare at it. Okay, so think about the ice cream cone. What can I divide it into? Okay, I heard a circle and a triangle. That's close. What am I really dividing it into? Semicircle, or half a circle and a triangle. Sorry, some of these are not stapled correctly. Trying to find. Well, because I tried to darken them because my copy was too light, and then I darkened it too much. Sorry, I'll let you make the copies for me next time. Okay, so half a circle and a triangle. So what's going to happen in this chapter is that sometimes you're going to be asked to find the area of a shape that is not just a simple shape. You're going to have to divide it into different shapes. You're going to be using what's called the area addition postulate, which basically says the area of a region is equal to the sum of the areas of its non-overlapping parts. Meaning, you would find the area of the triangle, and you would find the area of half a circle, and you would do what with those two? Add them together. So that's your area addition postulate. Just reminding you that you can divide shapes into different shapes and add them all together. But notice it says non-overlapping, because even though hopefully your ice cream is going all the way down inside your cone, you're not going to find the area of the other half of the circle because it's already covered by the triangle. Does that make sense? This chapter, everything's going to be two-dimensional. When we get to chapter 11, we're going to take these shapes and make them three-dimensional. So what will that ice cream part turn into instead of half a circle? Half a sphere. And what will that triangle turn into when it's three-dimensional? A cone, hence the name ice cream cone. So, good job. All right, so first formula that you already knew was area of a parallelogram. Jonah told us that he thought it would still just be base times height. Here's where they're showing you why it's that formula. If you have a rectangle that's base times height and you cut off one corner of a triangle there, you can reattach it to the other side so it still has the same area. So your parallelogram can still be found by doing base times height. But notice that your height is now not the side of your parallelogram. This is not the height, this is not the height. The definition for height should be the perpendicular distance between your two parallel bases. And here's the part that's going to make it harder. So make sure you're looking up here right now. When you draw that height in, notice that you could draw it here, which now creates what kind of triangle? A right triangle, which means they may not give you the height. You may have to solve for the height, and you may have to do that by using Pythagorean theorem or special right triangles or SOHCAHTOA. So be careful. You don't have to put your height right here. You could draw your height here, but you may not have enough information to find the height if you put it there. You may have to put it over on the corner to create a right triangle. Are you guys with me? Okay. So first formula that you have written down is area of a parallelogram is base times height. They do remind you in the notes what the area formula is for a square, what the perimeter formula is for a square, but we've already listed those. Again, they're going to state the height of a parallelogram is always going to be perpendicular to the base. They want to remind you, though, that it doesn't have to be inside your parallelogram. Don't forget that this could be the height. So your height could be outside your parallelogram. as long as it's perpendicular between the two bases. That's a terrible parallelogram. But perimeter for a rectangle, we already wrote it down. Here it is in your notes. And now we're just going to jump into some problems. So look at your problem here. One thing I didn't say, and please make sure you hear this sentence. I'll say it twice. On the test, if you do not start with the formula and you miss it, I will give you 0 partial credit. If you get it correct, I'll give you full credit. But if you miss it, the only way I'm going to give you partial credit is if you started with your formula on your paper. So I'm going to advise you every single time on every problem that you start with your formula. Okay? So what are we trying to find? Area, what shape? Parallelogram. What's our formula? A equals BH. Area equals base times height. Okay, look at your picture. What's the base? What's the height? Do we know the base? Do we know the height? Sean? Base is 11. If the base is 11, then what's the height? Okay, so we don't know the height. The height should be the perpendicular distance between those two bases, if that's our base. So this would be the height, and we're going to have to find it. Does everybody see how that's the height of the parallelogram? Okay, but 11 doesn't have to be what we use for the base. You could use the other side, 34. If you used this side, though, then this would be your height. It would be the perpendicular distance between these two bases. But we don't have enough information to find that height. So we can't use the 34, but does everybody see how it doesn't matter which sides you use, your height can shift. Okay, so 11 is going to be our base. Let's plug that in. Now we need to find our height. How can we find our height? Pythagorean theorem, but in my triangle, I only know one side. Where are you getting the second side? Very good. This other part of Chapter 10 that's going to be challenging is that it's going to go back and be all about quadrilaterals. And that means you have to remember your properties from Chapter 4 about quadrilaterals, or 6, I think it was, Chapter 6. So remember, in a parallelogram, that opposite sides are congruent. So if this is 34, this is 34. So now we're going to do Pythagorean theorem to find that height. What would my Pythagorean theorem be? Okay, I heard it 2 different ways and both were correct. 30 squared plus h squared equals 34 squared, or you can say 34 squared equals 30 squared plus h squared. I already know 30 squared is 900 plus h squared. What's 34 squared? 1,156. Subtract 900. Make sure you're taking good notes so you have this to look back at. H squared equals what? 256. Take the square root of 256, and what is h? 16. Plug it into your formula over here. What's 11 times 16? 176. And what are our units? Millimeters squared. Don't forget to square your units because you're finding the area. Questions? Okay, so just knowing the formula, plugging in the information, but sometimes you're going to have to solve for some things first. Okay, look at the next one. On this one, and this is where the algebra comes in, when you have to work this kind of a problem on the test, I will be very clear and add in these words. In terms of x. So it says find the height of the rectangle where the base is 3 inches and the area is 6x squared plus 24x minus 6 inches squared. In terms of x, what does that mean? Don't need to solve for x. It just means that you're going to still have an x potentially in your answer, and that's okay. What are they wanting us to find? The height. So you're just trying to solve for h, the height. If it still has x's in your answer, that's okay because you can be in terms of x. All right, what are we going to start with on our paper? Not starting with numbers. What am I starting with? Formula. Area formula for what shape? Rectangle. What's the area formula for a rectangle? A equals BH. Area equals base times height. Plug in what you know, look for what you don't know. What's going to go in for A? Good. 6x squared plus 24x minus 6 equals, what's going in for B? 3. And we don't know H. That's what we're trying to solve for. So what are we going to do using our algebra skills to solve for H? Divide by 3. So we'll just divide by 3. Make sure you divide every single term by 3. And I write it this way just so I don't forget to divide every term by 3. You can write it, just divide by 3 on both sides, but oftentimes students will forget to divide every term. So be careful. What do we get here with 6x squared? 2x squared plus 8x minus 2 equals H. What are my units? Inches or inches squared? Just inches, because we're just finding the height. We're not finding the area. You could have left your inches in your work if you wanted to. This would have been inches squared, and this would have been inches, and that helps you see that one of your inches is canceled out. But just remember, if it's not area, it's not unit squared. Are we good with that? Okay, so we're just solving for a variable. Don't let the x part make you all stressed out. You can have an x left in your answer. All right, next one. What do we want to find here? Perimeter of what shape? Rectangle. So where do we start? Careful. What are we trying to find? Perimeter of what shape? Rectangle. So what formula should we start with? Perimeter equals what? 2b plus 2h, okay? Plug in what you know, look for what you don't know. So find the perimeter of the rectangle. Looking at the picture, what do we know that goes into this formula? Base. So we have 2 times 21 plus 2 times h. Do we know what h is? No. Sometimes you're going to get to this point and you're going to be stuck and you can't go any further without using what else they tell you. So now they tell us the area. So we're going to shift to what formula? Area equals. What's the area formula for a rectangle? Base times height. Okay, so start with what you're trying to find and then look to see, do you get stuck? Is there nothing else you can do? Then go back to your problem. Where can you go from there? So now plug in what you know. What's the area? Okay, so 79.8x squared minus 42 equals, what's the base? 21. And we don't know the height. So now we're back to what we just did on the previous problem. What do we need to do to solve for the height? Divide by 21. Again, make sure you're dividing every term by 21. So what do we end up with here in front of x squared? 3.8. 3.8x squared minus 2 equals h. So we started with perimeter, couldn't find it because we needed to know the height, switched to area because they gave us that information, solved for the height. Now what do we need to do? Plug it in. So we're going to take this expression and plug it in. And so again, if this were on the test, I would put in terms of x so that you would know that you could still have an x in your answer so that you're not freaked out if you're like, oh my goodness, I have an x. How do I find x? That's not what you're trying to find. Okay, so plug it in. We have 2 times 21 plus 2 times 3.8x squared minus 2. Make sure you put that in parentheses so that you know to distribute. What's 2 times 21? Gemma, are you with me? 42 plus, what do I have here? Distribute. So what do I get? 7.6x squared minus 4. Is that my answer? No, what do I need to do? Simplify, combine like terms. So I have a 42 and a negative 4. What does that become? 38. Write your answer, oops, like you should have learned to do in Algebra 1 in descending order. So perimeter will equal what? Very good. Write your answer so that it's in descending order of exponents. X squared, then x, then your constant. And what are our units? Centimeters or centimeters squared? Centimeters, not squared, because we're finding the perimeter, not the area. Questions so far? Okay, so just using some algebra skills today, quite a bit as we go through the notes. Next thing in your notes switches to the trapezoid. The trapezoid is very closely related to the triangle. They look very similar, but the trapezoid has two bases. Have you seen this formula before? Okay, I thought you probably had, you just hadn't, maybe didn't remember it. So your trapezoid formula is just like your triangle, 1/2 base times height, but because you have two bases, you have to add them first. So the area of a trapezoid is going to be 1/2 base 1 plus base 2 times the height. So add the two bases, then 1/2 sum of the bases times the height. Remember that your bases are your parallel pieces. So one more time, I'm going to warn you up here. Your height, it can be drawn anywhere in here as long as it's perpendicular to the two bases. But sometimes drawing it right there is not going to be helpful. Sometimes you're going to need to shift it so that it ends up making a right triangle over here. Do you guys see this right triangle? And they may give you the side of the trapezoid and you've got to find the height by using Pythagorean theorem or special right triangles or something like that. Okay, so be careful. All right, there's your formula. We're just going to jump in. I'm going to skip this one. This one's super simple. You just plug the numbers into the formula. Okay, they give you everything. So I think you can do that easily. I'm going to skip that one. And let's look at this one. Find the base of the triangle with the given area. What are we going to start with on our paper? The formula. Formula for what shape? Triangle. What's the area formula for a triangle? 1/2 base times height. Again, you can put base times height divided by 2. It just depends on what's easier for you when you have to work backwards. So you decide what is easier for you. All right, plug in what you know, look for what you don't know. We're trying to find the base, and we know the area. So n for a goes 15x squared equals 1/2. We don't know the base. What's the height? 5x. Okay, at this point, it's can you do the algebra to get b by itself? What would you guys like to do to try to start getting b all alone? I would divide by 5x also. I think that's probably the easiest. So I'm going to divide both sides by 5x. They cancel over here on the right, and we're left with 1/2 b. And what's 15x squared divided by 5x? 3x. Remember that 15 divided by 5 is 3, and then when you divide with the variable, you subtract the exponents. 2 minus 1 is just 1, so we're left with x to the first power. Is everybody okay with that? All right, and then we still need to get b by itself, so what do we need to do? And that's what I would do. A lot of people say divide by 1/2, but really when you're dividing with a fraction, that's the same as multiplying by the reciprocal. Christian, you with me? Okay, so I'm going to multiply both sides by 2. So b is equal to, the 2 and 1/2 cancel. What's b equal to? 6x, and what are my units? Centimeters. Again, on the test, I would have in terms of x, just so you know you can have an x in your answer. Questions? Okay. Go ahead and try this one on your own, and then we'll check it. I'm just going to remind you one more time, I'm seeing a few people not starting with their formula. It's a bad thing to do in case you make a mistake on a test. Get in the habit now. First thing you should do is write the formula down. That formula should contain no numbers unless it's a 1/2. Then plug in your numbers. Another reason it's good to do that is because you start memorizing it because you've written it so many times. When you think you have an answer, let me know and I'll check it. It's not correct. I'm going to give you about 30 more seconds. Keep working. Yes, that's correct. Good, don't forget your units. Nicholas, don't forget your units. Good, Sean. Okay, just for time purposes, I'm going to come back to the board. It's okay if you're not done, keep working, but look up here and kind of check as we go. So you should have ended up with 19 millimeters. If you didn't get that, definitely pay close attention up here. Again, I would start with area trapezoid. A equals 1/2. Don't forget it's base 1 plus base 2 times the height. Plug in what you know. Area is 231. Do we know base 1? Yes, it's 23. We don't know base 2. And the height in the picture is what? 11. Okay, there's a lot of different ways you could work it from here. Somebody tell me what you chose to do first. Okay, I heard two different things just now. One person said distribute and another person said divide by 11. Both ways would work. Just be careful if you choose to distribute that you're only distributing to what's in the parentheses. You do not take half of 11, only half of the 23 in the B2. I would probably argue that it's a little easier to go ahead and divide both sides by 11 first and get rid of that 11. But again, you can work it either way. What's 231 divided by 11? 21. So we have 21 equals 1/2 of 23 plus B2. Raise your hand if you divided by 11 first. Okay, those of you that divided by 11 first, what did you do next? Okay, again, you could distribute the 1/2 at that point, but I still would argue that I think it's easier because you're trying to get the B2 by itself, so it's better not to start putting more stuff with it, but take it away from it. So I would say get rid of that 1/2, and that's by dividing by 1/2, which is the same as multiplying by 2. So 2 times 21 is 42. The 2 and the 1/2 cancel, and we have 23 plus B sub 2. And then what did we do to get B sub 2 by itself? Subtract 23. And so that now you end up with B sub 2 equals 19 what? Millimeters. Anybody need me to work it a different way because you didn't get 19 and you don't understand where you went wrong? Okay, moving on. Okay, last two formulas for today are going to deal with the rhombus and the kite. And again, it's going to be really important that you remember your special properties of your rhombus and your kite. Do you guys remember in chapter 6 making a big long property sheet? Okay, if you have forgotten your properties and you're having trouble on the homework, find that property sheet and go back to it. You won't be able to use it on the test, but it'll help you start to remember them before the test. But I'm going to point out some properties as we go through these that you need to remember. So you might just be able to look at these notes. In a rhombus and a kite, remember that the diagonals were perpendicular. So you may want to draw this on your notes just to remind yourself if you had a rhombus or if you had a kite. That's terrible. if you had a rhombus or you had a kite, the diagonals in both of them were perpendicular, meaning that they formed four what? Right angles and four right triangles. Okay, a couple of other things to remember in your rhombus and your kite. In the rhombus, what did that mean was true about all four triangles? They're all congruent because only in the rhombus do the diagonals bisect each other. In the kite, that's not true about both diagonals, but in the rhombus, remember that the diagonals bisect each other, and therefore all four triangles ended up being congruent. Because in your rhombus, remember, all four sides are congruent. So it had four congruent triangles. Those are things you may want to jot down just to remind yourself. In the kite, you only had two pairs of congruent sides. So how many pairs of congruent triangles did you have? Two. Two pairs. The top two where they have the same side, and then the bottom two. So this one you had two pairs of congruent triangles. And only one diagonal got bisected. This one. Right? One of them got bisected, and it's the one where the two triangles would have been congruent. Going this direction, that's not true. This little piece and this piece are not the same length. Okay. Because a rhombus and a kite have perpendicular diagonals, they have the same formula. But before we look at their formula, back to chapter 6. A rhombus is always what other shape? A rhombus is not always a square. A square is always a rhombus. A rhombus is not always a square. What is a rhombus always? A parallelogram. Remember when we talked about our big Venn diagram parallelograms? A rhombus and a rectangle, if they were overlapping, became a square. But a rhombus could just be a rhombus. A rectangle could just be a rectangle. But rhombuses and rectangles are always parallelogram. So if a rectangle has the same area formula as a parallelogram, which is base times height, then what should one of our rhombus formulas be? Base times height. So a rhombus, and this will be on your formula test. Both formulas for the rhombus will be on your formula test. So the first one is a rhombus is base times height. Area equals base times height. Because a rhombus is a parallelogram, so it has the same area formula. That one will be used probably the least. The next formula I'm going to show you is the formula that is often used in this chapter, but again, it just depends on what information you know. If you know the base and the height, this is the formula you'll use. The rhombus and the kite, though, have the same formula from here if we're talking about the diagonals. So your formula for a rhombus and a kite is area equals 1/2 D1 times D2. That's diagonal 1 times diagonal 2. 1/2 D1 times D2. 1/2 D1 times D2. Most missed formula besides the circle. Circle's always missed. Circumference and area every year, all the time, students confuse those two formulas. Be very careful. Second most missed formula on this test is trapezoid and kite. Because in the trapezoid, what do you do with the two bases? Add them. In the kite and rhombus, what do you do with the two diagonals? Multiply them. Somebody, guaranteed, is going to add their diagonals and multiply their bases. Be careful. That is not what you do. You add the bases in a trapezoid, you multiply the diagonals in a trapezoid and kite. D1 times D2, B1 plus B2. Be very, very careful with those two formulas. Okay? At this point, then, it's just plugging in your diagonals and working the problems, but they always, of course, make them a little bit harder. So we start with something that's pretty simple right here. Go ahead and see if you can find D2 of this kite. Try it on your own. We'll check it. Get it. It's correct. Good. Go on and see if you can do the next one. So remember, start with your formula, plug in what you know, look for what you don't know. Those are your steps every time. Perfect. Double check your math here. Yeah, put your down. Perfect. Don't forget your units. Okay, we're going to go ahead and check it. Not cross multiplying occurs when you have fractions and you're doing diagonal cross. This is going back to foiling and distributing, but we'll talk about it in just a second. Okay, so here we go. Area of a kite. Again, if you want any partial credit, you're starting with your formula. A equals 1/2 D1 times D2. When I say start with your formula, I mean no numbers. You're not plugging in the numbers from the problem. You're starting with the formula so I can see what did you know, and then you're plugging in your numbers after that. So 238 equals 1/2. We do know D1. D1 is 14. And we're looking for D2. Okay, what did you choose to do at this point? You could multiply both sides by 2. I would say there's probably a little easier way. 1/2 of 14. I would probably just go ahead and do 1/2 of 14. But you could multiply both sides by 2. What's 1/2 of 14? 7. So we have 7 times D2 equals 238. What do we do from there? Just divide by 7. So D2 should have equaled 34. What units? Inches. Not squared because you're not finding area. Questions on that one? Okay, they get a little harder on the last two here, and then there's a word problem. So let's look at this one. First of all, I want to warn you about notation up here, so please look at this problem even if you've already worked ahead. If it says D1 equals or D2 equals, that means they're giving you what? The whole diagonal. If you take off that D1 equals, so pretend with me for a minute that that was not on your picture, and all you had was this little arrow pointed right here. No D1 equals. What would they be giving you? Half of it. And it's half because this is what shape? A rhombus. In a rhombus, the diagonals bisect each other, right? And therefore, each piece is equal. But be careful. That's not going to always be true if it's a kite, right? In a kite, they're not always both bisected. So be really careful. But if it says D1 equals, then they're giving you the whole diagonal. D2 equals, they're giving you the whole diagonal. Okay? So just be real careful with that. So if we want to find the area of our rhombus, we start with what? Area equals 1/2 D1 times D2. Or what's our other formula for area of a rhombus? Area equals base times height. So it could be that they gave us information about the base and the height. Did they? No. So we don't want to use this formula. We want to use this one, but don't forget that you do have two options for your rhombus. Okay, then you just plug in your diagonals. 8x plus 7 and 14x minus 6. And I would remind you that we had a bonus question on last test or the test before, not this last one, but the test before that, I can't remember. And several of you did not know how to multiply binomials. This goes back to Algebra 1. What do you do when you have a binomial times a binomial? Distribute. And some teachers teach it as what acronym? FOIL. Just depends on what you want to do. I would tell you, I think it'll be easier for you to leave the 1/2 alone for now and multiply D1 and D2 first. Then distribute your 1/2. That would be my advice. So I'm going to leave my 1/2. I'm going to FOIL, which is just a fancy way to distribute. 8x times 14x, 8x times negative 6. That's giving us the first and the outer terms. What is 8x times 14x? Be careful, it is 112x squared. Again, that was what a lot of you did wrong when you were doing that question. You did x times x and just put x. It is x squared. What's 8x times negative 6? Negative 48x. Then you go back and you distribute the 7 to both terms. That's where you're going to get the inner and the last if you're using the idea of FOIL. Otherwise, just distribute the 8x to both and then go back and distribute the 7 to both. What's 7 times 14x? Should be 98x, right? And then 7 times negative 6? Negative 42. Okay, what can we do from there? Say it again. Simplify. What's negative 48 plus 98? 50. So we have 1/2 of 112x squared plus 50x minus 42. Now what do we need to do? What do we need to do? Divide by 2, which is the same as distributing that 1/2 to everything. Make sure that you distribute it to everything. What's half of 112? 56x squared plus half of 50, 25x minus half of 42, 21. That is our area. Again, on the test, it would say in terms of x. And what are our units? Centimeters squared. Questions? Please ask me now if you're lost anywhere with the algebra. The geometry part's just, do you know the formula? Can you plug it into the formula? Everything else today is, can you do the algebra? Okay, last question that we're going to look at here is the hardest one. Find the area of the kite. And then we're going to stop. You can try the other one on your own and apply it to the homework. But last example I'm going to do in the class. What are you going to start with on your paper? Formula, which is? All right, area equals 1/2 d1 times d2. You're multiplying the diagonals. Look at your picture. This is a kite. They don't tell me which two sides are the congruent sides, so we're going to have to assume which ones we think look like they're the congruent sides. Which ones look to be congruent? Which ones? Okay. Left side, which two sides on the outer edges of our shape look to be congruent? In a kite, you have two pairs of congruent sides. Okay, the top left two, would you guys agree those two look to be congruent? And then the bottom right two look to be congruent? Okay, because that's important. You have to know which pieces are the congruent pieces. All right, what do we know about the diagonals in a kite? Perpendicular. Elijah, you with me? Okay, so we know our diagonals are perpendicular, which creates what kinds of triangles? Right triangles. We need to know the lengths of the diagonals. Right now, we don't know any of the diagonals. We know just this little piece is 28. What are we going to do? Okay, Pythagorean theorem with, okay, with the 35 and this triangle right here. Does everybody see that this would be a right triangle? And we know this is 28, this is 35, and we can solve for y. What would my Pythagorean theorem be? 35 squared equals y squared plus 28 squared. What's 35 squared? 1,225 equals y squared plus, what's 28 squared? You should be writing this down. 784. And then we're going to subtract 784. So we have y squared equals what? 441. And then we're going to take the square root. So what is y equal to? 21. Okay, here's the part you got to be careful about. In a rhombus, both diagonals are bisected. But in a kite, only one diagonal gets bisected. It's the one where the two triangles would land on top of each other because they're congruent. So if this is 21, what do we know this length is? 21. So what is one of our diagonals? 42. Does everybody see how that's 42? But do you agree that the next piece is not going to be 28? Those are not congruent, right? Okay. So one diagonal, I'm going to go ahead and plug it into my formula, is 42. Now I need to find the other diagonal. What am I going to do to find it? Pythagorean theorem again. Using which triangle? Which two sides? 29 and 21. Good, Elijah. So we have this triangle here. 21, 29, and I'm looking for x. So what will be my Pythagorean theorem for that one? Okay, and I'm hearing it both directions again. It doesn't matter where you put the c squared on which side of the equation. So it could be 29 squared equals 21 squared plus x squared, or 21 squared plus x squared equals 29 squared. We already know 21 squared is 441 plus x squared equals, what's 29 squared? Thank you, 841. Subtract 441. So x squared equals 400. Take the square root. What is x? 20. Okay, I did that really fast. Are you guys with me? So if x is 20 and the other piece is 28, what does that make our second diagonal? 48. So then we just come over here and we plug it in and type it in on our calculator. One thing I want to warn you about that I see every now and then is sometimes students make the mistake of distributing 1/2. Do we distribute 1/2? No, because the only time you distribute is when you have what mathematical symbols? What makes you think I've got to distribute? What has to be in your parentheses? What math symbols? This is a multiplication. We don't distribute when we have a multiplication. Plus or minus. When you have a plus or minus, when you have a parentheses, something plus something or something minus something, and then you have a number out here, that's when you distribute. If you just have 1/2 diagonal 1 times diagonal 2, there's no plus or minus sign. You don't distribute. Okay, so you just do half of 42 and then multiply by 48. So what do we get? 1008. What are the units? Inches squared. Okay, I said I wasn't going to do the last example, but I do remember I need to warn you about something on the last example. So before I do, questions on this one? Christian? Mm-hmm. 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 It's totally fine. Mm-hmm. So Christian's question, just because it could be helpful for everybody, is instead of writing his equation like this, he's writing it as d1 times d2 divided by 2. And that's totally fine. Just like for the triangle, you can do base times height and then divide by 2. So whatever's easier for you. Okay, I want you to look at this last example because you're going to have problems like this, and this is pretty tough. I'm going to give you 2 minutes to try it on your own, and then we're going to check answers. Before I do, though, when is the homework due that I'm giving you? Thursday. But you're not going to wait till Wednesday or Thursday morning, which would be ridiculous. Okay? So I'm going to go ahead and start passing it out. But guys, this is the hardest one, so try it. I'm going to give you 2 minutes. Lily, you with me? Okay, try your breath. Do you think you have it? Okay, hold on. I will warn you that the perimeter is not a whole number, and your answer should not be rounded. It should be in simplest radical form. The perimeter is not a whole number, and it should be in simplest radical form. The area is. Find perimeter and area. Don't give up. Keep trying. These are the kinds of questions you got to persevere. Okay, hands up if you think you know the area. Evan, what do you think it is? Area is 1. Hands up if you think you know the perimeter. No decimals, has to be in simplest radical form. Do you know what it is without putting it in your calculator? Okay. All right, we're going to check it, Jonah. You probably see if what we get when you plug it in is the same decimal, but your answer, since it didn't say to round, would have to be in simplest radical form. Okay, everybody up here with me. First of all, it says, make sure you're with me, find the perimeter and area of the parallelogram leftmost. So first of all, you need to recognize that you're trying to find the perimeter and area of this parallelogram, right? Okay, area, go back to what it says. This is a rectangle with a base of 4 inches and a height of 2 inches. Easiest way to find the area here would be, if this is 4 inches, what is each little piece? 1. So that means this is a 1 by 1 square, which means if I look at each square, how much of the square do I want? Half. What's 1 times 1? 1. So each square is split into a half, which means we have a half and we have a half, which together makes a whole. So the area is just 1 inch squared. Now, make sure that you understand how I got that. Are we all good with area? Was 1 unit for the entire square, and then we're just doing a half of it and then another half? Okay. Perimeter's harder. So think back to your triangle that you have here. If I'm looking at this triangle, and I want the perimeter, Jonah. Okay, go ahead. It is 2 plus 2 square roots of 2. Good. David, you had it too? Yeah. Awesome. Okay, so let's go through what Jonah and David did here. First of all, we know this side is 1 and this side is 1. Would you guys agree with that? So 1 plus 1 is 2. That's where they got the 2. Now we have to know this side of the triangle. What kind of triangle is this triangle, though? A right triangle. Be more specific. What kind of right triangle is it? I heard somebody say it. Isosceles. Don't pack up yet. I'm not going to let you go. Stay with me. It's isosceles, which means, what are these angles right here? JP, stay with me. What are these angles right here? 45, 45, 90. Easiest way to work it would be then to know if this is 1 and this is 1, then this is 1 square root of 2. And 1 square roots of 2 plus 1 square roots of 2 is 2 square roots of 2. Hardest way would have been to do Pythagorean theorem. 1 squared plus 1 squared equals c squared. You could have done that, but that's longer. Okay, that should be inches. Homework's due Thursday. I'm giving you a lot of time.